Hello and welcome to another Algebra 1 video tutorial. In lesson 12.4, we'll be factoring x squared plus bx plus c. So our goal will be to factor quadratic expressions when the coefficient of the square term is 1 and the square term here is like x squared. So when that's 1, we're going to factor those type today and a little more complicated tomorrow. Okay, so the big idea is some quadratic trinomials of this form can be factored into two linear factors, such as what we mean by two linear factors would be like the product of two binomials. So in this case it would be x plus something and x plus something if it's both positive. Okay, so that's what we're going to try to do. Take something of this trinomial form, quadratic, into a product of two binomials, so we'll call this factored. Okay, so in last lesson we saw y equals a times the quantity x minus r sub 1 times the quantity x minus r sub 2. You should notice that's factored form. So this right here looks like factored form, quantity x plus 4 times the quantity x plus 3. That's factored form. So we're going to try to go from a standard form equation, quadratic, into factored form, because you saw how helpful it can be to have factored form. You can get the x-intercepts quite easily. Then you can go get the vertex, and then you can do all sorts of analyzing from that. Okay, we're going to have this a value be 1 today to make the factoring a little bit easier to start with. So if you had the quantity x plus 4 times the quantity x plus 3, if you expanded that out, it would be x squared plus 3x plus 4x plus 12, right? If you did all the multiplying, so x times x is x squared, x times 3 is 3x, 4 times x, and then plus 4 times 3 is 12, okay? Now, we're going to name some of these things here. And the square term is x squared. The linear term is with just x to the first power, so the linear term here would be 7x, and the constant term would be 12. Okay, because that's just this simplified. Okay, so if we had a negative and a positive, so we have quantity x minus 6 times the quantity x plus 8. If we multiplied that out, we'd get x squared plus 8 times x minus 6 times x, and then minus 6 times 8, so minus 48. When you simplify that, you'd get x squared plus 2x minus 48. Now, the point of showing this is, if you know this process, you can go from this form, standard form, into this form, which is factored. So then, on this one, if we have x squared plus 2x minus 48, what we want to do is get it back to this form. So today, we're going from standard form back to factored form, which is pretty helpful. Okay, so if we have just a generic one here, quantity x plus p times the quantity x plus q, that's going to give x squared plus qx plus px plus pq. The point of this is this linear term is going to be the sum of p and q. So the linear term is going to be the sum of p and q, and the constant term is going to be the product of p and q. So you got to know that relationship in order to get back to this form. So standard form, we're going to go back to factored form. So let's try a handful of examples and see if you can get this. Okay, so factor x squared plus 11x plus 18. So what we want to do is we're going to look at 18. That's going to be a product of two numbers. And 11x is going to be the sum of two factors of 18. So what I've done here, or what you can do, is you can make just a factor box to try and factor this. So we know it's going to be an x and an x to get x squared. So I know the first term in each of the binomials. Okay, and I have a positive 18 and they add up to a positive 11x. So I know it's going to be plus and plus. Okay. Now, we need the product to be 18 and the sum to be 11. So we could try 1 and 18. So if we try 1 and 18, that's going to give us 18. We know that for sure. But then this will give us x and 18x. That sum is not 11. That sum is going to be 19x. We don't want that. So that won't work. So we go the next two. We go to 2 and 9. So let's try this to be a 2, this to be a 9. So this is going to be an x by 9. Okay, this one didn't work, this one didn't work. And this one's a 2 by x. So we knew we were going to get x squared and 18. Now 2x and 9x do make 11x. So our factored form would be the quantity x plus 2 times the quantity, the other side, x plus 9. So that would be the only factors that work. Because if we use 3 and 6, they multiply to be 18, but 3 and 6 would make 9x. So 3 and 6 wouldn't have worked. The only one that works is the quantity x plus 2 times the quantity x plus 9. All right, let's factor x squared minus x minus 30. So this was a little harder because you have a product to be a negative 30. So that means 1 has to be positive when 1 is negative. Okay, so we know it's going to be x and x. That's the only way to get x squared. Okay, now we need this last term to be a product of negative 30. So factors of negative 30. Factors of negative 30. Okay, so that could be negative 1 and 30. It could be 1 and negative 30. It could be 2 and negative 15. It could be negative 2 and positive 15, and so on and so forth. So what pair of factors is going to give us a sum of negative 1? Well, if sum of negative 1, if 1 is positive and 1 is negative, that means they only have a difference of 1. So that means we've got to have factors of 30 that are only 1 apart. So that would be 5 and negative 6, or negative 5 and positive 6. Which one has a sum of negative 1 would be this one, because this one would be negative 5 plus 6 is 1. This one, 5 plus negative 6 is negative 1. This one, so you can see now how these others are not going to work. That would be a difference of 29. Difference because one's positive and one's negative. This would be negative 29. Those don't work. This would be negative 13 and positive 13. So the one we want, the pair we want, is 5 and negative 6. So we could have x plus 5, x minus 6. This is going to be a negative 6 by x. This is going to be a 5 by x. Then we get x squared plus negative 1x plus negative 30. So it's going to be x plus 5 and x minus 6. That is the factored form of x squared minus x minus 30. All right, let's try t squared minus 8t plus 16. Okay, now we know it's got to be t and t. That's the only way to get t squared. So that's pretty set in stone. So these are all going to work because they're 1. Now when we get tomorrow, there's going to be a coefficient here that's going to make this a little more complicated. But if you can get the easy factoring, tomorrow won't be too bad. Okay, now we need a positive 16 for the product, but they add to negative 8. So the only way to get a positive product is either they're both positive or they're both negative, but this middle term is a sum of negatives, so we know it's going to be t minus and t minus, so they're both going to be negative. Now, what factors of positive 16 add up to negative 8? So we have, so it could be negative 1, negative 16. Well, their sum is negative 17. Negative 2 and negative 8, their sum is negative 10, so it's not either of those so far. We go to 4 and 4, negative 4, negative 4. Well, their sum is negative 8, so it's got to be that. So it's going to be t minus 4, because this is negative 4t. This is negative 4t. Those two add up to negative 8t, so that's what we wanted. T minus 4, t minus 4. We could also, since this is the same thing, we could say this is quantity t minus 4 squared. Either one works. This is the most simplest answer, simplified answer, and that's the factored form of t squared minus 8t plus 16. All right, let's try t squared minus 12t plus 16. Okay, so once again, remember, it's got to be t and t. That's the only way to get t squared. Now we need a positive 16, but they add to negative 12, so we know it's going to be a negative and a negative. Okay, so we need the factors of 16 that add to negative 12. So it could be negative 1, negative 16, but we know their sum is negative 17. Negative 2, negative 8, their sum is negative 10. Negative 4, their sum is negative 8. And that is all of our integer pairs. So what do we say about this one? We say that it cannot be factored. It's a prime polynomial over the integers, because that's one that cannot be factored into factors of lower degree with integer. Key idea there is integer coefficient. We could factor this with square roots and some stuff that are not integers, but we cannot factor it with integers. So this one is not factorable. Not factorable. All right, factor m squared plus 5m minus 24. We know it's got to be m and m. That's the only way to get m squared. Now we need negative 24, but their sum is positive 5. So we know one has to be positive and one has to be negative because the product is negative 24. So what could we try? Well, it could be negative 1, positive 24, 1 and negative 24. So their sums are 23. and negative 23. We need a 5. So we need to have a pair that has a difference of 5. So is it 2 and negative 12? No, because that's negative 10. Is it negative 2 and positive 12? No, because that would be positive 10. Is it 3 and 8? 3 and negative 8, which would be negative 5. No, we're close though. We need the opposite of that. We need negative 3, positive 8, because their sum is 5. So this has to be m minus 3, because that would be negative 3m. And this has to be m plus 8, because it's 8m. Those two add up to a positive 5m. So it's going to be m plus 8 and m minus 3. All right, hopefully you're getting the hang of this. It's not that difficult if you kind of list out what the factors are, try the factor box here, and make sure that they all add up to what they're supposed to and get factored form. All right, we're going to try 4 more. You may pause the video before each one and see if you could factor this. I won't show the factor box. I'm just going to show you the answer. So before you get the answer, maybe you want to pause it and give it a quick try. Okay, so this one's going to factor into x and x. It's the only way to get x squared. Now, the product is 12, but the sum is 7. So is it 1 and 12? No, because that would be 13. Is it 2 and 6? No, because that would be 8. Is it 3 and 4? It has to be, because that makes 7. So x plus 3 and x plus 4 is the factored form of that. All right, x squared minus 17x plus 42. I'll give you a chance to pause it if you want to. Okay, x and x, the only way to get x squared. Now, it needs to multiply to be 42. It's a product of 42, but add to negative 17. So we know they have to be both negative. To multiply to be positive, but add to a negative, they have to, both terms have to be a x minus and x minus. And in this case, so is it 1 and 42? No, because they got or negative 1 and negative 42. No, they got to be negative 43. 2 and 21, negative 2 and negative 21. That's not going to be 3. It's going to be a negative 3 and a negative 14. Those multiply to be positive 42, and they add up to, the linear factors would add up to negative 17x. All right, third one, pause it if you want to. We're going to try x squared minus 4x minus 12. This is going to be x and x. They multiply to be negative 12, but add to negative 4, so we know it's going to be a negative and a positive. Okay, and the larger one appears to be negative because it takes on a negative sum. Okay, so we need 2 and 6, where 6 is negative. Negative 6, positive 2, because we get x times x is x squared. X times 2 is 2x. Negative 6 times x is negative 6x. So 2x and negative 6x add up to negative 4x. And then negative 6 times 2 is negative 12. So that would be that one. And the last one, factor p squared plus 6p minus 7. So this is going to be p and p. They multiply to be negative 7, but add up to 6. So we need one of each. We need a minus and a positive. The larger one is positive when the sum, because it adds up to a positive 6. The only factors of 7, integer factors of 7, are 1 and 7. So it has to be a minus 1, a plus 7, because p times 7 would be 7p, and then a negative 1 times p would be negative p. So those add up to a positive 6. And that would be factored form of that trinomial. All right, so that's a lot of factoring, but hopefully you got the hang of it in those examples. And your assignment will be 12-4. Page 740, number 2 through 28 evens. Thanks for tuning in, and we will see you next time.